going to reflect in the identity line y equals x. It's called the identity line. Oh, also, please remember, if you want actually to fill in notes and not have to handwrite the whole thing, you need to have it printed off and Google Docs on Monday. That's what I'm trying to do. If you don't print it off, you handwrite it. Up to you. So, y equals x, the identity line. So, this is how I can ask you to find the inverse. I can say y equals f negative 1x, I can ask for that. Or I can say x equals f of y. When your x's and y's are flipped, that is actually the inverse graph. So if I want the inverse, I can say find the inverse. Or I can say find this, or I can say find this, and that's the inverse as well. Any of those are the same way of asking for inverse. Okay? So we have the graph of y equals f of x equals x minus 5 squared shown. It's not showing, we're going to draw. So you can put it into your calculator, x minus 5 squared, and you plot it. It's going to be at positive 5 and 0. 1, 2, 3, 4, 5. 0. Once you have transformations, it's easy to draw these graphs. My original quadratic is at 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, correct? This graph is just a quadratic move 5 to the right. So 0, 0 can be 5, 0. It's going to be 4 and 1. 6 and 1. Literally choosing the quadratic 5 to the right, correct? So that's the graph of f of x. I'm going to label it. You want us to write it according to the inverse. Inverse graphs are just x and y split. So if there was a point on my graph at 6 and 3, on the inverse graph it's going to be at 3 and 6. If there's a point on my graph at negative 1 and 4, it's now going to be at 4 and negative 1. The signs don't change at all. You literally just make your x be your y and your y be your x. That's it. That's all inverses are. Okay? So how do we come up with an equation that way? Well, we make our x's be our y and our y be our x. So we're going to have y equals this normally, right? So we're going to have x equals y minus 5 squared. Our x's became our y, and our y became our x. And we'd be done. We could be done at this point. However, they're probably going to have the equation in y equals, correct? Is this wrong? No, it's not wrong. It just probably isn't going to be the answer they're going to have if you don't. So we need to be able to solve for y, because that's what they're going to have. So I have y minus 5 squared. I need to get rid of the square first. So I'm going to take the square root. When I take the square root of anything, I have to put a plus or minus sign in front of it. Do not forget that, or you will only get half of the graph. You only get half of the inverse drawn graph. Okay? And you'll know because if you put that into your calculator, you're really only going to have to drop. What did I forget? Oh, it's plus minus. So now I have y minus 5 equals plus or minus root x. And I can just switch sides with these. Nothing changes. And then I add my 5. So I'm going to get y equals 5 plus or minus root x. Now, how the heck do you put a 5 plus or minus root x in your calculator? You have to put it into two of them. So, for example, in your y1, you're going to have 5 plus root x, and in your y2, you're going to have 5 minus root x. You can't put them in at once. You have to put them in two separate equations. You try that. Put in 5 plus root x, 5 minus root x. And then your y3, put in the original. Put in y equals x minus 5 squared. And maybe make it shaded thicker, right? If you want to go to the far left and enter and then make it thicker graph, we did that. I was thinking I originally was thicker. You're going to see a sideways parabola. Why? What do they tell you happens when you take the inverse of something? Your x becomes your y, and your y becomes your x. Really, really, really easy to draw the inverse if you have the original. Take every point off the original, flip it, and redraw it. That's it. So, this is at 5 and 0. I'm going to go 0 and 5. 1, 2, 3, 4, 5. This is at 4 and 1. I'm going to go to 1 and 4. This is at 3 and 4. I'm going to go to 4 and 3. This is at 6 and 1. I'm going to go to 1 and 6. This is at 7 and 4. I'm going to go to 4 and 7. Oh, that's that. Now, it reflects on the identity line. The identity line is y equals x. So let's draw that graph and see. Y equals x means every y coordinate is the same as every x. So 0, 0. 1, 1 would be on the line. 2, 2 would be on the line. 3, 3 would be on the line. -1, -1. -3, -3. Negative 0.666, and negative 0.666. That point would be on there too. I prefer you not to try and plot that one. Yeah. Where do these two graphs cross? They cross on the identity line. Why would they cross on the identity line? The line y equals that. We reflected on the x. Where was the invariant point? On the x. We reflect on the y. Where were the invariant points? On the y. When we reflect on the identity line, where are the invariant points going to be? On the identity line. So I can give you any graph. This is an aside. It's not to do with this graph. Just pay attention to this gets everyone on test. If I give you a graph like this, let's say, it goes to -1, -1, and it does this. So that. And I say to you, okay. I say to you, how many invariant points are there? Most people will look and they'll try to find the points that are like matching. So like -1 and -1 and -2 and -2, etc. Right? So if I draw the identity line, I can tell you how many invariant points I have. I'll just put an end on this graph so we know it doesn't keep going. I'll put an end on this one. This graph has terribly drawn in here. Whatever. Let's not pretend it's at -1, -1, because this is stable. Oh my, it's terribly drawn. So 0, 0, and 0. So if you want to find out how many invariant points there are, if it just asks you the number and it doesn't ask you what they are, just draw the line y equals x and count how many times it crosses through. That's where it's going to stay, right? Those crosses on, it always stays invariant on the mirror, right? On the reflecting line. If you wonder how many times it crosses, and they give you the equation, type the equation into y1, type into y2, y equals x. And y equals put in x. See how many times it crosses through, because it'll draw the identity line for you, right? Okay. Mark the invariant point. So we mark the invariant point. So right here, right here. How does the graph of x -1 compare to the graph of y equals x of x? It's reflected in the identity line. Line y equals x. xy becomes yx. This is f of x. Look at inverse of x. So think about that. If the domain on the original graph is xer, the range on the inverse graph would be yer, because your x's just become your y. If the range on your original graph was y is greater than 2, the domain on your inverse graph would be x is greater than 2, because you're literally just flipping your x's and y's, right? So your domain becomes your range, and your range becomes your domain. So what some people do on the test, I'll give you an original, let's say I give you the original equation, and I ask you for the range of the inverse. People go and they change the x's and y's, and they find the new equation, and then they find the range of the inverse. What could you have just done? If you found the domain of the original, you have the range of the inverse. Just change the x to y. Right? You don't even have to find the new equation. Because the domain of the original is the range of the inverse. You just have to change x and y. Because if x was greater than 2 on this graph, when I draw the inverse of it, y is going to be greater than 2. Okay. Okay? So we're going to sketch the graph. We have 0 y equals x. That's going to sketch the graph of the inverse. All we do, pick some points, main points. I'm going to pick this point. And then I'm going to pick one that crosses through the box. So I'm going to pick this one and this one. So I'm going to pick up the crossing. This one is on this one, this one's on this one. That's the main turning point. That's all I need. I don't need 1,800 little points between flips, right? So I'm going to draw the graph. Let's get -1 and 1, 2, 3, 4. Let's get -1 and 4 for f of x. So for x inverse of x, it's going to be at 4 and -1. It's your x and y split. Don't change signs. People think you need to change signs. You don't need to. Just flipping x and y. So we have 4, 1, 2, 3, 1, 2, 3, 4, and -3. Then another point I have is 1, 2, -3, and 1 on the original. It can become 1 and -3. Then I have 1 and 0. That's going to become 0 and 1. And you know you're right if you draw your identity line. 0, 1. If you can't actually see that they're reflecting on that line, which I can see, there's the invariant point. They're crossed at that identity line. If you're crossing the identity line, you're both. I mean, you did it right. They should intersect on the identity line. But you can also see that they're reflecting. It's a little harder to imagine this one. But you know what's great about tests is you can turn them. I can't turn my screen. But you can turn your test so that this is a horizontal line. It's a lot easier to see that it actually is reflecting when you make it a horizontal line or a vertical line. When it's on the angle, it's a little harder for people to see it. But you can turn your page so it looks horizontal for you and see if it looks like it's reflecting half the same amount as it. Okay? Obviously, you can imagine it better when it's on a horizontal. Okay, we're going to sketch the following. Go. So this point at -1, -2. -6 and 0 is going to be at 0 and -6. This point is at -4 and 1, 2, 3, 4, 5, 6. And that's going to be a 6 and -4. you're someone who messes up your points consecutively, write out the original, then write out the flip, and pause. I'm going to connect these right away because they're connected here. So I would do a point connect, do a point connect, do a point connect. So here's -1 and 6, so it's going to get 6 and -1. This one is at 1, 2, 4, and -3, so it's going to be a -3, 4. And this one's at 1, 2, 3, 4, 5, 6, 7, and 0, so it's going to get 0, 7. Again, we on 0, 0, 1 more, 2, 2. Where are they intersecting? -0. Give me y equals square root x minus 2. Find the inverse. Now I told you when you take the square root of something, you'll take the positive or negative, correct? Some people will say, this has a plus or minus sign in front of it, and they'll draw both. Does it have a plus or minus sign in front of it? No. Did you take the square root of something to get it to be that way? No. And this just has a positive sign, guys. The only time you get a plus or minus sign is when you physically take the square root of something, you have to put the plus or minus sign in front of it. Okay? I didn't take the square root of this. This is just the square root of x minus 2. That's all it is. So, let's think about this. Don't draw this, just pay attention, so we'll think about transformation. So the original square root x graph is at 0, 0, 1, 1, 4 and 2, 5, 6, 7, 8, 9, and 3. So that's the original. This is the original. Don't draw it, just pay attention. The original y equals square root x graph, right? But that's not this. This is square root x minus 2. So that entire thing is shifted what? To the right. I don't need a calculator because I know transformation. I can just plot all my parent functions, which the parent functions are the ones before you've actually done any transformation, and then transform them. So kind of check your calculator, which will be the university away from you for the most part. Usually they take it away, you know, I don't know. Even though I use basic one. We need to be able to know how to draw these without always relying on a calculator. So, to the right, to the right, to the right, to the right. So this red graph is actually the graph you need. The green graph I just used to get me there. So I'm at 2, 0, 3, 1, 6, 2, 11, 3. Okay? They want the inverse of it. Probably get the equation first. Even if you don't get a graph, you're like, oh, you get the equation, swap the x and y. X equals square root y minus 2. Remember what does square root work itself back out to? Quadratic thing square root. So let's see if you can do that other way. Square. Now we have x squared equals square root of y minus 2. And then we have, square root gone, I don't know how to rewrite it. And we have x squared minus 2 equals y. You guys remember anything, whenever you get a radical, you have to state restrictions? Remember that from grade 11? What's the rule about radicals? You find negatives under them, correct? The moment you have a variable under a radical, you should state restrictions every single time. So, on this function here, I would have to say x minus 2 has to be greater than or equal to 0. So x has to be greater than or equal to 2. Yeah? That's why there is no more graph below 2 here. That's why there's no graph to the left of 2. Because x has to be greater than or equal to 2. Okay? Well, think of this one. We have square root, we have y minus 2. So now I have y minus 2 has to be greater than or equal to 0. So y has to be greater than or equal to 2 when I solve that. That's our restriction. And when I draw this graph, I'm literally going to have no graph below it. This is radical, the very end of 20-1. Very end, so very close. So, I want to draw the new graph. go 2, 0, and make it 0, 2. 3, 1, and we can get 1, 3. 6, 2, we get 2, 6. And then I have a graph. Now you might think there's only part of a graph here. And this is a quadratic. Okay? I'm going to show you the next graph. The next part of this graph is where standard of excellence comes in. The next part, the next page. We're going to flip to the next page. The next page is where standard of excellence comes in. I have seen questions like this written. I have seen questions like this on the diploma. I have seen questions like this on your unit test. So we're going to pay attention to this. This is where that gets explained. So we give us x squared plus 1. Do you remember how to tell something is a function or not? Passes the vertical line test. Something is a function passes the vertical line test. For every x, there's only one y. So if I draw this, it's a function. Every quadratic is a function because I draw a vertical line, and at any point in time, if that crosses more than once, it's not a function. Well, every vertical line I draw on that graph is going to only cross once, so it's a function. If I have an inverse of a quadratic, we see what that is. Like a sideways quadratic, correct? So we get a plus or minus sign for a radical. It is absolutely not a function. In a whole bunch of slides, it crosses more than once, so it's not a function. Okay? So how do they make this a little bit harder? So to say, A, the equation of the reflection of a line y equals x. Once again, this is another way of asking for the inverse without saying the inverse, or f negative 1, or f of x equals y. That's another way. This is another way to ask it. What's the equation? So let's figure it out. The equation would be x equals y squared plus 1. We swap our x and y and make find the inverse. Move the 1 over. X minus y equals y squared. Take the square root. When you take the square root, you get plus or minus. Right? So now we have y equals plus or minus square root x minus 1. Which is great. So this is the graph. Graph and state the domain and range of this. Will we have to actually find this equation in order to get the domain and range of the inverse? No. The domain of this is just a parabola that's at positive 1 and 0. So it goes like this. The domain of the original graph, this is the original. You can draw it on the actual graph and then it. The domain of the original is XCR. If I did that in interval notation, that's negative infinity to plus infinity. The range is y such that y is greater than or equal to what? YR. Yeah? That's the original. I didn't find the inverse at all. Now I want you to graph and just state the domain and the range of the inverse. What's it going to be? Easy. The domain is x is greater than or equal to 1. The range is YR. You just literally flip the x's and y's like all we've done the whole time is flip x and y, x and y, x and y. So my domain is x such that x is greater than or equal to 1, XCR. Because it's going to look like this. There's going to be a 1 here, and it's going to look like this. So x is greater than or equal to 1. Yeah? That's what this graph, if you plot in your calculator, is going to look like that. The range is YR. Because the domain of the original is that. This is where the standard of excellence comes in, part C. So that's great. We get another graph. It's not a function. So they say to you, describe how the domain of f of x is the original one, could be restricted so that the inverse is a function. How can we restrict this original parabola so that when we flip it sideways, it only crosses once? Good. I will restrict this particular equation to x is less than 0, less than or equal to 0, or x is greater than or equal to 0. If I restrict it to that, I only have this arm or this arm, which means I only have this arm or this arm, right? So if I restricted my domain, so this is how they do it on diploma style questions. They'll say, what restricted domain of the original would result in the inverse being a function? And they'll give you A, B, C, D, okay? particular equation, I could say yes, x is less than or equal to 0 or x is greater than or equal to 0. They usually do not pick that as the option. So they'll give you x is less than or equal to -2. Would that still work? If x is less than or equal to -2, I only have this part of the graph. If I flip that part of the graph, would it be a function? If I flip that part of the graph, would it be a function? Yeah, it would just be this piece. It would only be that part. If I draw vertical lines through that, would that still be a function? Yes. So you just have to give a domain of the original that is either part of this arm or part of this arm. So what's another one they'll give you so that it's wrong? They'll say, okay, x is less than or equal to 2. If I give you the domain of the original being x is less than or equal to 2, that's actually this whole thing here. Which is actually here. Is that black graph a function? No. So you could say x is less than or equal to 0. You could say x is greater than or equal to 0. You could say x is greater than or equal to 2, x is greater than or equal to 3, x is greater than or equal to 100. All those would work. X is less than -1, x is less than -2. You just have to give piece, portion, or the whole part of just one arm. You can't go where you're going to get more than one arm, because when you flip that sideways, it's not going to pass. Does that make sense? This is the hardest thing to understand from inverses that people get wrong all the time. You're just restricting your original so that you have one arm or the other arm, or at least a piece of one arm. You can't have more than this. You can't have over the vertex, or it won't work. So if I'm going to restrict this, I could say x is less than or equal to 0. I could say x is greater than or equal to 0. I could say x is less than or equal to -1. I can't say greater than or equal to -1 because that would be from here all the way to here, and then I have that little bit of a bubble, right? I can't have that. I can have x is greater than or equal to 40. You can't see it, but this graph keeps going on forever, right? That's what I find the hardest difficult to get. So if I ask you to do an inverse of an equation, you literally put the x and y and solve for y. If I ask for an inverse of a graph, you put the x and y plot. If I ask for the domain and range of the inverse, I just find the domain and range of the original. Whatever's x becomes y, whatever's y becomes x. That's all I do. You can find the inverse graph, plot it, and then do it from there if you want. The bottom here is the assignment. I don't expect you to do it all, but at least do one of each time. So like 1B, 2B, 3A, 4, do 1 of 5, 1 of 8. Do enough so that you actually know what you're doing. Because it isn't a hard lesson, but a lot of people, for some reason, think it's not hard because they don't do any questions from it, and then they bomb all the questions on the test on it. Okay? So do those to your, what you may think you need. I'm going to hope that you do what you need to. In university, they take in about 9 questions in math, and the rest they assign to you and don't check. And if you don't do them, you're just going to bomb the test. Okay? You guys have to be able to do your homework without me physically checking it every day. If you don't, this is going to be a very scary year. I'm going to hand out that hand-in. You're going to get to work on it tomorrow. I'll give you the answers at the end of class. You can ask me questions on it. It's not for marks. It's for you to practice more diploma style.